Hi there. In this video, I'll be doing a quick review of the quadratic formula. I'm sure you've seen this in Algebra 1, but you may have forgotten it. So let's look at an example of this quadratic equation, 2x squared plus 8x minus 4 equals 0. So using something called completing the square, there's a way we could solve this. And let me show you. Just watch this. You're not going to have to do this like I'm doing it. Right off the bat, I might notice everything is divisible by 2, so I'll divide everything by 2 just to make my life simpler. And now I will move the 2 to the other side. Most of the time, if we wanted to solve by factoring, for example, keeping a 0 here is best, but we're going to do something a little bit different. What I'm going to do is I'm going to notice, and this is called completing the square, that if I add 4 to each side of this equation, what I get on the right factors, what I get on the left factors. This factors as x plus 2 times x plus 2 equals 6. So I have that x plus 2 squared is equal to 6. What that means is that x plus 2 is equal to the square root of 6, which is an awkward number, but you can put that in your calculator, or x plus 2 is equal to the negative square root of 6. Just like with negative 3 and 3, I square both of them, I get the same answer of 9. When we say something squared has an answer, we have to think, oh, maybe this thing we're squaring is positive, or maybe it's negative. And solving each one of these, I could say x maybe is negative 2 plus root 6, or x is negative 2 minus root 6. I simply subtracted 2 from each side, although I wrote the negative 2 first because that's going to start to look a little more familiar. So these are exact answers in terms of radicals. I could plug this in my calculator and get a decimal approximation, but sometimes it's really nice to have what's called the exact algebraic answer. It's not a nice number like 2 or 3, but we know exactly what it is in terms of algebraic ideas, not just a decimal approximation. And in theory, we could, I'll emphasize here, we could always follow these steps to solve a quadratic equation, even if we don't know how to factor it. But instead of doing those steps, what you can do is you can do them abstractly and then just remember the result in terms of a formula. So if I were to start with this, right, it's the same form, 2x squared plus 8x minus 4 equals 0. ax squared plus bx plus c is equal to 0. This is just abstract. If we went through all the same steps, we would get x is negative b plus or minus square root of b squared minus 4ac all over 2a. The plus minus here really means there are two answers. One of them is what we would get if we put a plus there. The other is what we would get if we had a minus there. I want to emphasize it's saying there are two answers, but the two answers have a form that's so similar that we combine them with this plus or minus symbol. This is a formula worth memorizing. In the short term, you can look it up whenever you need it. Definitely have it handy. Have it clearly written somewhere where you can refer to it. But in the future, it might be expected that you have this memorized. It's super useful. So let's look at an example. And I will just copy this so that it is available as we need it. Oh, that didn't work. I'll just write it out. Sorry. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So what if I want to solve this equation? One thing I'll point out is we have a 3 here. In order to use the quadratic equation, we have to have the quadratic set equal to 0. So I'll do that first. What I really have here is x squared plus 10x minus 3 is equal to 0. So this is a quadratic. A is the coefficient in front of x squared, so we would say a equals 1 in this case. B is the coefficient of x, so we would say b equals 10. And c is our constant, that's negative 3. If we see minus, we just think of it as a negative. So let's do our formula. Just watch. X equals minus b would be minus 10, plus or minus the square root of b squared, 10 squared is 100, minus 4 times a times c. Usually I just write those out and simplify later, over 2 times a. So let's just simplify. What I have here in the radical is 100 plus 12. So this is the square root of 112. Now, this number maybe is not the easiest one. I will tell you that 112 is equal to 4 times 28, which is equal to 4 times 4 times 7. Hopefully I'm doing that correctly. Yes. So this is 16 times 7. Something you might remember from Algebra 1 is when we have radicals, it's nice if we can write them in a really good form. So the square root of 112 is the square root of 16 times 7. And when I have multiplication inside a radical, you can break it up. That only works with multiplication and division, not with addition and subtraction. So I'm going to write square root of 112 as the square root of 16 times the square root of 7. And I'm doing it that way because I know the square root of 16 is 4. And remember, I'm trying to get the nicest algebraic answer. I might notice that I can factor a 2 out of the numerator. I have 2 times negative 5 plus or minus 2 root 7. And 2 over 2 cancels. So this simplifies to negative 5 plus or minus 2 root 7. So there are 2 solutions. At the end, I like to write them separately just to emphasize that I know what the plus minus really means. One of my solutions is negative 5 plus 2 root 3. One of them is negative 2 root 7, sorry. One of them is negative 5 plus 2 root 7. One of them is negative 5 minus 2 root 7. And we'll do a little work in class to just practice simplifying radicals because I think you're very rusty at it. So here's what I want you to try. Use the quadratic formula to solve this equation. Hit pause and give it a shot. And if you like, you can try evaluating on your calculator and also solving by graphing to see if those square. So I hope you've paused to give this a try. We have a equals 1, b equals negative 6, c equals negative 2. So from our quadratic formula up here, I would have x equals negative b would be the opposite of negative 6, which is 6, plus or minus the square root of b squared, which is 36, minus 4 times a times c, all over 2 times a, which is just 2. So if I simplify this, I have 36 plus 8, which is 44. And on the side, I'll just note that 44 is equal to 4 times 11. So we can write this as 6 plus or minus the square root of 4 times the square root of 11 all over 2. So that's 6 plus or minus 2 times the square root of 11. As in the previous problem, we can factor a 2 out of the numerator, which cancels with the 2 in the bottom. So we get 3 plus or minus the square root of 11. Two solutions. X could be 3 plus the square root of 11, or it could be 3 minus the square root of 11. So if you did this by graphing, you'd have decimals, but you wouldn't really know where those decimals came from. This is telling us algebraically exactly what those numbers are. Now, you'll notice that because of the plus minus symbol, in the examples we've seen so far, we got two solutions. We got one solution when we put in the plus and one when we put in the minus. That might not always happen. We can predict the number of solutions by looking at the expression under the radical. I'll keep writing this formula. What happened in our examples is we took the square root of something positive, right? We had like square root of 6. So there was one version where we added the square root of 6 and one version where we subtracted the square root of 6. So that's why we had two solutions, but we'll see that there are other possibilities. So a bit of vocabulary here is this word discriminant. When we have a quadratic equation in standard form like this, the thing under the radical, b squared minus 4ac, that's called the discriminant. And this is related to the word discriminate. The original meaning of the word discriminate means to make some sort of decision or selection. Usually today we use it to mean to make an unfair decision. But here, the discriminant is making a decision about how many solutions there are. So whenever the discriminant is a positive number like we saw before, that would be like, oh, I have square root of 6. So one answer is plus the square root of 6. One has minus the square root of 6. I get two solutions. So if the discriminant is positive, I get two solutions. Now, if the discriminant were 0, what would that be? The square root of 0 is 0. So even if I put a plus or minus in front of that, that's like saying, oh, either you add 0 or you subtract 0. Well, those aren't different things. If I have some expression where you add 0 and then I change that to subtracting 0, it's the same thing. So I'll only get one solution. The plus and minus wind up giving me the same answer twice. But if the discriminant is negative, that means we have to take the square root of a negative. And you probably know that you can't do that. If you know something about imaginary numbers, you know there's a scenario for that. But if we're talking about real numbers and things we can see on a graph, we can't take the square root of a negative. So once you see that the discriminant is negative, you know there's no real solution. So a really nice feature of the discriminant, it allows us to do a quick little computation. And without going through all of these steps, we can quickly predict, does this equation have a solution, and how many solutions will it have? Maybe that's all we're concerned with. If you want to find the solution, you need to do extra work. But if you just want to know if there's a solution, the discriminant does it for you. So let's look at an example and then we'll wrap up this section. So this is a word problem. So after t seconds from being hit, the height of a golf ball in feet is given by this formula. The 16 here has to do with the force of gravity. The 1/12 of a foot would mean 1 inch. This is assuming that it's being hit from a tee 1 inch off the ground. And the 85 has to do with how hard it was hit. So this is an accurate formula based upon how someone might actually hit a golf ball in real life. So the question is, does the height ever get to 115 feet? So really, we're thinking about this equation. Height of 115 is negative 16t squared plus 85t plus 112, and we want plus 1/12. And we want to know, does this equation have a solution? And that's exactly what the discriminant does for us. So rather than find the solution, let's just see, is there one? This is just asking a yes or no question. So in order to use a discriminant, I do have to set things equal to 0. So we get a rather awkward number there if we subtract the 115. So we have A is negative 16, B is 85, C is negative 114, and 11/12. So our discriminant, b squared minus 4ac, would be 85 squared minus 4 times negative 16 times negative 114 and 11/12. And I will spare you having to do the arithmetic, but this comes out to negative 129 and 2/3 when all is said and done, which is negative. So when the discriminant is negative, and again, you don't have to memorize this all by yourself. You can think, if the discriminant is negative, it means I'd have to take the square root of a negative when I solve this thing. That's impossible. So basically, it's impossible to solve this equation to get a real number that makes any sense in terms of time. So the answer here is no, right? This equation has no solution. Which means the answer to this yes or no question is no. We will never get as high as 115 feet following this formula. Okay, that's enough for now. I will end the video.